Go ahead.
Okay. Okay, so good morning to everybody. This is the project of the Water Quality Group called the use of remote sensing for water quality dynamics in the northern Gulf of California, Mexico. The researchers are going to be myself, José Andrés Vargas-Solano, and my teammates, Andrea, Rebeca, Lara, Cera, and Maria Emilia Rechimont. So our scientific question was related to what it's the potential of remote sensing data to assess uh, this kind of dynamics that we're going to be able to find in the upper Gulf of California. So to do that, and we're not going to explain this whole slide taking in consideration time, but the important thing here is that if you see the map, you're going to see here in the right side that the Gulf of California is going to be divided, according to Lopez Martinez in 2023, in 5 sites. And this division is going to be put according to the concentration of chlorophyll and temperature that we're going to be able to find in those water bodies. So this was our proposed workflow when we use the data from Landsat to use the thermal bands that we have there. From PACE level 3, we use the chlorophyll concentration and the reflectance to try to work some spectral indexes in that area. And we use the Copernicus Marine Service nutrient concentration to try to think about correlations that we're going to be able to find there. If it was necessary, we did some pre-processing, but it was not necessary in this case. And to make the analysis, we use a Google Earth Engine, Jupyter Hub, and with that, the Jupyter Notebooks to get some water retrieval parameters like spectral indexes, nutrient concentration, water surface temperature, and other things. With that nutrient concentration, we created a statistical analysis to try to see if there were significant difference according to the season, or maybe the upwelling and downwelling currents relationship in that area. And in the post-processing part, and it's the current state of the research, we need to start creating the machine learning model to try to detect anomalies. So to start with the results, you can see here from the PACE level 3 data that we have a whole time series for a year to try to get like all the seasons, the concentration of chlorophyll that we're going to be able to find in the upper part of the Gulf of California. So we're going to see that at the beginning, we have the concentration in the mouth of the California River. And with the pass of time, we're going to see that there is a whole redistribution of that concentration, and we're going to be able to find it in the winter ending of the month in the center of this water body to come back to the initial state. And to put in practice some of the things that we learned, we created a graph where we measured that concentration of chlorophyll in a transect to try to see the difference in time. And we can see here that, for example, in the mouth of the river, we have the higher concentration of chlorophyll. Even in 1 month, we have let's call it like a huge increase in that exact pixel. And we can see that in the pass of time, we're going to see an increase in the middle of the water body. So that means that we have a whole change in that part of the area. To correlate that kind of results, we calculated the concentration of silicate, nitrate, and phosphate, but we're only going to show the plot of silicate taking in consideration the time that we have and to be in a schedule. So you're going to be seeing here the same kind of proposal result where you're going to see the change in the concentration of silicate through time. In this case, we see that in June, we have the higher concentration in the mouth of the river, and we're going to see less distribution through time. And then we're going to see that by the beginning of the winter, there is an entrance of silicate from the middle part of the water body. So that means that something is happening in that part, that it's letting the silicate come back to the, let's call it the upper part of the gulfs. And we have to take in consideration the importance that that kind of nutrient has for the phytoplankton community. So it's an important, let's call it, nutrient that we have to pay attention in that area. To take in consideration another factor, we have the temperature, and here we have the mean value of the water surface temperature that we took from Landsat, and we can see that the 6 first months, we don't really see any kind of like difference related to the whole dimension of the water body. But in the other 6 months, we can see that according to the change of the station, we could see a reduction of the temperature of the water with colder waters in the mouth of the river, and maybe that creating a whole reduction in the whole other part to go to the middle and then come back to the initial state. And to put in practice and see the whole capacity that this spectral resolution from the PACE surface reflectance bands has, we created a different type of spectral indexes. In this case, we are only going to show the ones related to chlorophyll, because in that way, we're not going to put together like the turbid ones with the chlorophyll ones. But the important thing here is that you can see that, for example, the pattern that we can see between the NDCI and the chlorophyll highlight, it's very similar with different normalized index values. But according to the things that we could read a little bit with literature, we don't have to use, like, for example, normally different chlorophyll index in a hyperspectral system, because it has his disadvantage. And the MCI, that it's going to be at the beginning, there is a reduction, but then we can see that but by the beginning of the winter, we have an increase in that part for all of them. And to be able to see that change, and the part that what's more excited for us is to try to see that even if we plot different kind of spectral indexes for the same thing, we can see that we are going to see different results according to this capacity of this spectral resolution that this new kind of technology has, to be able to see something that at the beginning it was invisible for us. So maybe we can try to put some points and try to see the spectral signature. Maybe that red coloration is not really something, but a lot of backscattering, but it's the kind of questions that are going to be raised with that thing. So related to the challenges, we lack the in situ data to create the machine supervised model. There was a huge deal according to the permutation of the project, because in the beginning we wanted to work with water quality to detect pollution and illegal water discharge. But maybe if we turn around the project and try to see what are normal conditions to then try to detect like what it's not a normal condition, it's going to be a good way to approach the project too. There were all of us. It was the first time that we were working with PACE, and usually we use R. But in this kind of seminar that we had with people with a lot of patience, we pushed to the Python type of code. The same thing with the GitHub. It's something that it was very new to us, and we have to work a little bit with that. And for some members, it was the first time that they were working with remote sensing analysis, so we took the time to teach them and talk about the results and everything like that. For future improvements, so we need a machine supervised model to try to detect anomalies. If we had the date for that anomaly, we can try to use the PACE image to try to play with that spectral resolution to try to see or define what kind of disturbance or component is there that is creating that kind of change in the concentration or the value. It will be better to use the whole gulf, because in that way we're going to be able to see the whole dynamic. We saw that for silicate, something is happening in the entrance of the gulf, so that means that we have to explore in that end. And we have to take in consideration the Colorado River, so maybe use the RZ stream platform to see the dynamic in that part, that it's going to have an effect in that end. And maybe try to recreate the 5 ecological parts using the algorithm of the concentration of the PACE to see if they have the same result or not. This is the slides that is going to be there for the access of the code and the GitHub. And obviously, we need to thank Ellie and Ryan for their patience, for everything that they were able to tell us, because I know that there is a lot of work behind everything that they were able to teach us and share with us. We want to thank to all the other organizers and tutors that maybe we didn't interact together, but we know that you were there with your expertise and the incredible new material that we have. And well, the sponsors, right? So thank you.
Thank you, Jose. That was awesome.
Awesome.
Oh, I didn't saw that I didn't put the camera, but I hope that there is no trouble with that.
Oh, good. We have time for one question. Next group, if you can get your slides up and ready once we have this question. So I have a question. Like you use the chlorophyll product. What do you think would be like the next step of the like different PACE products that you saw over the week? What's the next one you might want to look at?
Uh, I wanted to use the there was one related to the photosynthetic carbon, like organic carbon, and it's going to be plot in the system, because in that way we can try to see if they match, if they don't, why they don't, if we can find any difference in that end. And maybe because we didn't have much time, we choose to work with the monthly data, and it's possible that we're losing, like, let's call it outliers related to external causes to the increase of the chlorophyll or not. So that's another thing that with more time, it will be better to work with a daily basis. But yeah, I think that if I have to choose, I will choose that base product to add to the whole system.
All right. Well, congratulations, team. That's
Thank
really great work. Let's see. Do we have our next team ready? All right, red drum. You will see, hopefully you guys can see the timer. I've got it going there so you can watch
Yeah,
that.
yeah, we can see it
Okay.
when we start the presentation.
Perfect.
I'm actually in full screen mode and I can't see the timer.